Welcome again to Simplified RSA. The guys who makes it looks easy. I'm Mr. Maimane, and we are your number one learning platform in the country, if not worldwide, I think. But anyway, on today's question, we are deviating a bit from the hectic algebra. So, well, there's still going to be some variables involved because now that's what I'm saying. Um, Actually, before I introduce the question for today, you might be wondering, why do we have Mr. Man over here? But um, hold that thought. Here's the question of the day. Let me put the question this side so we can have this side viewed as well. Excuse me. So it's an interesting question. The question reads, a bakery kept record of the number of loaves of bread a tuck shop ordered daily over the last 18 days. The information is shown in the table below. So now we have the information in the table. Each and every number inside the boxes, like each and every number inside the table represents the number of loaves that were ordered by a tuck shop. So it's just that the bakery kept the record. Interesting, right? I love bread too. And I mean, bread is something that is bought every day by every household. At some point, I feel like here's the thing. Before we dive deep into the question, here's the thing. I want you to understand that at some point, we don't have to look at mathematics as the word states mathematics because that's scary. And also statistics, the word is scary too. It's just that like I'm saying, everyone is familiar with the whole process of a tuck shop, bread being delivered at the tuck shop. Everyone, whenever you live in the hood, you can see bakeries coming in and out, dropping bread. And you can tell there's probably a certain number of bread that's been delivered there. Now, until they say now you have to apply this under statistics. If you're in grade 12 now, staying in the hood, you've seen bakeries dropping bread in tech shops so many times. But now here's a question. Because it's there now, it becomes like, oh, how did I get here? And I'm like, now I'm gonna try by all means to make sure we don't see the mathematics inside this type of a question, but rather interpret it as to how can we solve or rather how can we get the marks? Like how can we get the marks without thinking as hard as this is mathematics? Because this, my friend, is a real life situation. It's something which we see in real life. We see, like I say, I'm going to read the question again. A bakery kept a record of the number of loaves, um, a number of loaves of bread a tuck shop ordered daily over the last 18 days, which is what we know. Now, 1.1.1, and then they want us to calculate the mean number of loaves of bread ordered daily. They want us to calculate the mean number of loaves ordered daily. And you hear the fancy word mean again, you're like, yo, gulunguluam. And here's the funny thing. When coming to the formula to calculate the mean, normally, as easy as the application of the formula is, um, mathematicians, they differ. Like there are some who wants to make things look complicated because of the status of being a mathematician. But then there are some who say, like Einstein once said, everything can be as simple as possible, but not simpler. Well, as simple as possible as it can be, but not simpler. It's just that there's some point where something you have to apply more um, skill or knowledge or whatsoever. I don't know where I'm going with that line. Let's stick to the question actually, because now I'm starting to preach things that are out of this lane. Let's stick to the question. Now, all I was saying is that the word mean, the mean number, is just a fancy way of saying average. And normally, this is how it's represented in the formula sheets. Now, if you look at formula sheets and different representations of the mean, some will tell you that the mean is represented as, maybe they will say the sum of xi from I being from 1 or 0, whatever value it is, up to n into 1 over n, something like this. Look, it looks way very complicated. Some can even simplify this further and say it's just the sum of all the observations divided by the total number of observations. This and this is still the same thing. But for someone who doesn't have a mathematics background, it's hard to interpret that this and this is the same thing. And what this means, it actually means that if you have x1, x2, now the axis will be represented by numbers now, x2, x3, up to xn. What this formula means, I always say this all the time, and I'm not going to get tired of this because I'm not sure if we do understand each other sometimes. This formula means that the mean, like you actually just have to add all the observations. You add all the observations up until xn, and then you divide by the total number of observation, which is that last number that you get from there. So the interpretation of this formula, this and this, like I say, is the same thing. This is how you represent, you interpret it. So now, for a question like 1.2, as you can see, is 2 marks. Adding those values the way they are from the table, from our table, we have the following values. Imagine how long it would take to add up to 18. And now you are in an exam and time is running because you only have 2 hours to complete your exam. So now the mean is going to be the first entry on our table now is 10 plus 11 plus 13 plus 14 plus. You can add all the numbers as you can up until 41. And then all this divided by the total number of observation, which is 18. So now this is the answer for 1.1.1. If you were to answer your 1.1.1 and you start it from here because you understand the interpretation of the mean, of the formula for the mean. I wanted to say the mean formula, but then now it's going to take me somewhere also for another explanation. So if you understand how to interpret the formula for the mean, which is this, you can just add all the observations, you divide by the total number of observations. So you can add from the table as you see, as much as the last number is 41, the next number is going to be 40. You just have to add everything. It's just that now I don't have time to keep on adding and stuff. But now the answer that we're going to get from here, if we add everything, it's going to be 22. So you can go ahead and try 1.1.1. If you get 22, and then we are on the right track. So now you understand that the mean or the mean number is just another term for average. It's just a fancy word for average. You have the number of bread, the amount of loaves that were ordered daily for 18 days recorded in the table, right? Sometimes it is advisable, it's very much advisable to have a calculator that you can convert into a statistical mode, because here we calculated the mean manually. Because now imagine now they give you something like 25 values and you are in an exam, you have to add, maybe you are not sure if the value must come back and confirm and stuff. So sometimes we must believe in our calculators, that our calculators are very smart to can calculate some of the things for us, since we are allowed to bring the calculator in an exam. So it requires training for you to can be like, okay, sharp, I can do this myself. Here I have a sharp calculator. I don't know what whoever is watching here is the calculator they're using. Some people are using Casio mostly, and then some they use the sharp calculator. So now I want us to take our calculators to statistic mode. If you're using a Casio calculator, I don't know, man, before I publish this, I'm going to try to find a link that shows how to move to statistic mode on a Casio calculator. But then from this one, if you use a sharp, I think a sharp, it is universal function sort of. So if you want to store the data that you have on the calculator in the form of, so in a statistic mode, you go to mode, you press mode on your calculator. When you press mode, it's going to take you, it's going to show normal 0 or stat 1. You're going to press stats 1, and then it's going to say SD0 line 1 quad 2 for quadratic. So now this type of a data is a single data, so it's a standard data. So we're going to press 0 because we only have one entry. The time we're going to press line, it's when we are talking about regression line. But for now, if you don't know what I'm talking about, hold that thought until we get there. Now we are having a single standard data, so we're going to press 0, and then it's going to show stat 0. That's statistic mode 0. And then we're going to program our data here as it is. So I'm going to say 10, and I press enter. enter is under M plus. If you are using a sharp calculator to enter your data, enter is under M plus. So I say 11 because it's the second entry, enter, so it's data set 2. I say 13 because it's the third entry, then it's data set 3, and then it goes like that. I'm just going to enter everything there. 40, and then 40 is data set 17, and then 41 is data set 18. And then after entering your data set, you can see on top of 4, you have X that has the bar. So that represents the mean. So you just go alpha, and then you press that one. It's going to show the mean there, and then you say equals to, and then it gives you that. So that's the mean, which is 22, exactly as it is, without having to add manually like that. The coolest thing is the data that we have is already stored here. So all those things that they're going to want us to calculate, we're just going to extract the values from the data that we stored in our calculator without having to calculate, because now, like I said, some formulas are even more complicated, such that you wouldn't even take a chance to try calculate using the actual formula in an exam, because now time will run out, right? So let's move on to the next question, 1.1.2. Question 1.1.2, they want us to calculate, or they just, yeah, we have to calculate the standard deviation of the data that we have. Now, here is something big about this. We have sample standard deviation, we have population standard deviation in statistics. We have sample standard deviation, we have population standard deviation. Now, let me explain a little. A population is the entire thing that we are studying. That's a population. And then from the population, we scoop out a sample. So sometimes we can have 100 people that we want to study, but then because we can't go around and study the entire 100 people under statistics of whatever survey we may be doing. Let me put it like this, not to get anyone lost. Like I say, statistics is the mathematics of things that apply in reality. I would say I want to check how many people are employed in a community of 300 people, but I can't reach all the 300 people. Some are not at work. If I'm collecting that data, just knocking door by door and asking, are you employed or not? I just want to know how many people are employed. So I can take a sample of 30 people and conclude how many were unemployed in that community. So the population then represents the total of people, the total number of people residing in that community, and then the sample that I scooped out is what I'm studying. So in this case, and the number of bread, the bakery made a study and recorded. They recorded all the values in this table that we have. They are not stating if it's comparison with other bakeries. So we can't treat the data that we have, we can't treat it as a sample. We have to treat the data that we have as a population. I'm saying this because on the calculator, again, you have sample standard deviation and you have population standard deviation. So for this case, they want us to calculate the population standard deviation because we treat this sample as a population, because it's not a study of anything. It's the total of what is being recorded for 18 days. Like it's just specifically the total of bread that was ordered by that tuck shop from the bakery for 18 days. Is the full information. Hence, we treat it like a population. As much as it's 1 mark, I feel like I needed to explain that, because one might think it's a simple standard deviation, of which the value is always almost closer, but then it's good to be accurate, right? So to answer 1.1.2, this is how it should be. So now the population standard deviation is that. And you can see that otherwise, if you could calculate the sample standard, I'm just showing you the simple standard deviation could have been also it could have been maybe 10.73. The value is almost close, but then this is not what we want. This one is for if we're calculating the, uh, the, 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 the data that we have shows a population of the entire study. Hence, we calculating this. Before we answer the next question, keep in mind that the whole story is about a bakery delivering delivering loaf of bread in a tuck shop and the records that are kept of those loaf of breads. It's a question that is related to some things that we know or something that we can relate to in reality. Like as you can see here, we haven't factorized anything so far, right? So 1.1.3, they want us to calculate number of days, not number of loaves. They want us to calculate the number of days on which the number of loaves of bread ordered was more than one standard deviation above the mean. Like the English is so fancy, but to understand the question is very much important also. So your answer should be the number of days. They don't want you to calculate. They don't want you to add the mean and the standard deviation. Yes, the number of loaves of bread that are more than one standard deviation above the mean is actually just the addition of the mean and the standard deviation. So we're going to add the mean and the standard deviation and see how many loaves of bread are more than the mean and the standard deviation. And then we want to know how many days covers that amount that is more than that. Talk is cheap. Let me demonstrate what I'm saying. So for question 1.1.1 and 1.2.2, we did prove that the mean is 22 and the standard deviation is 10.17. Now, 1.1.3, the number of days on which the number of loaves of bread ordered was more than one standard deviation above the mean. This is what they mean by more than one standard deviation above the mean. You just add your mean and your standard deviation to see how many loaves are that. So the mean is 22 plus the standard deviation is 10.17. Therefore, one standard deviation above the mean is 32.17. This is one standard deviation above the mean. So we are looking for the number of days whereby the we are looking for the number of days whereby the number of breads are more than 32.17. And if we look on our table, it clearly shows that on the table you can see that from 21 we have 35, 35, 37, 40, 41. So from 35, if we count, 35 is one day, the other 35 is day 2, 37 day 3, 40 day 4, and then 41 day 5, meaning we have 5 days whereby the number of breads were more than 32.17. It starts from 35 up to 41, which is 5 days. So your answer is in days. Therefore, this is your final answer. But you had to get it by determining the one standard deviation above the mean, which is just the addition of the mean from the mean, you add standard deviation and then you get that. And then these are the number of loaves whereby the standard deviation was one unit above the thingy. And then by adding that, and then we determine the value, and then from then we calculate how many days does the table have more bread that are more than 32.17. So it's 35, 35, 37, 40, which covers for 5 days. That's 1.1.3. Now, as we move along, 1.2, I say again, the story is about the bread, the tuck shop, and the baker. So now, 1.2, somehow the tuck shop owner was not able to sell all the loaves of bread delivered daily. So every day, there's no way people can buy all the bread. There's sometimes some bread left behind, such that maybe I think the story goes where the bakery can take it back or sell it cheaper. I don't know how it goes, Mara. You can't sell all the loaves you order a day, or some can be sold the following day, but that's not another story. I think Kumakuleing here. It could be, but anyway. So now, since all the breads were not sold, the tuck shop owner, he then calculated actually maybe Kimakula, hey, but yeah. The tuck shop owner, he calculated the mean number of the loaves sold over 18 days to be 20. So the mean of the loaf sold, let's get it down. Actually, let me just remove everything here, and then we have all the information properly, so we can break down, so I can eat my loaf in peace. So 1.2. Don't forget that our mean, we found our mean to be 22 on 1.1.1 on 1.1.1. Now somehow this guy now, he didn't sell all the loaves, and then the loaf that were sold is equals to the loaf that were sold. He found the mean to be 20. The mean of the loaf that were sold is 20, meaning from 22, I mean, we can see that the mean of the loaf sold, why did I say sold? The mean of the loaf sold plus the mean of the loaf unsold should somehow give us the total mean. Let me say unsold, not sold, not sold. Should give us, so the mean of the loaves they bought, the one they sold, plus the mean that they didn't sell, it should give us the total mean. So if the mean of the loaf that were sold is 20, it means that the mean of the loaves that were not sold, it's going to be 20 minus 22, right? So mean not sold is going to be 22 minus 20, which is 2. So now of the 18 days, there were 2 loaves that were not sold each and every day. So now to get the number of total of loaves that were not sold a day, therefore the number not sold will be 2 times 18, which is then 36 loaf of bread. That's the total answer. So now, from the question, the guy calculated the mean of the loaf sold. All of the loaf of bread is sold. It was 20. And we know that the mean, the total average of the loaves anyway ordered a day is 22. So from the 22 average that he ordered a day, he sold 20 of them, meaning 2 is not sold. But I just went through that hectic calculation there because I know there are some people who are special, who care about the algebra like that. But otherwise, you could have just figured out from here, or if they sold 22 loaves, I mean, if they sold 20 loaves from 22, either way, the remaining loaves is going to be 2, which makes it 2 times 2 is a daily average, 2 times 18, because we have total of 18 days. Therefore, it's 36 loaves that were not sold in a day. I mean, it's the total of the loaves that were not sold in the total of 18 days, I mean to say. So this is the answer. For this next question, we don't need the bread anymore. We can let go of the bread. And no, I'm not putting it on the floor. There's a, yeah, anyway. So now 1.3 now is a graphical representation. Here's how the question goes. One of the 2 box and whiskers diagram drawn below represent the data given in the table above. So in that table of breads, which like now, like I say, the bread is fine. So on that table, the representation of all the information there, the mean, statistically, there's more of things we can break down on the data. They could have asked for the quartile. Actually, now that we are here, before we answer 1.3, it would be very much advisable to first understand the properties of a box and whiskers diagram. So here are the properties of the box and whiskers diagram. So the box and whiskers diagram, it shows us the minimum value, the first quartile, Q1. It shows us the median, which is halfway of the entire data if it is arranged in ascending or descending order. And then it shows us Q, which is Q2 as well. And we have Q3 and the maximum number. You can calculate the interquartile range as well from the box and whiskers diagram. So now all you need to do is just to look at the 2 diagrams before you answer the questions. You can see one, because what are they saying again? One of the two. So not all of them represent the information. But before you answer your question, you can tell, man, that which one does actually really to give you the full information, because there are some things already you know how to calculate. We might have not talked about the median, but everyone can calculate the median. I mean, if we calculate the median of this data, we know that with the median, we're looking at the middle term. Yeah, on 1.3, we're going to calculate the position for the median. The position for the median and position, the position for the median, we calculate it by n plus 1 over 2. Therefore, here we'll have 18 plus 1 over 2, which gives us 19 over 2. 19 over 2 is 9.5, right? Let me just confirm that. Yes, it's 9.5. So when we calculate 9.5 units, we go 1, 2, 3, 4, 5, 6, 7, 8, 9. 9.5 on a number line between 18 and 19, it's going to be, that means our median is 18.5. And if you look, according to 1.3.1, they want us to answer which one is representing which one of the two box and whisker diagram drawn above correctly represent the data above, and write your reason. So you can see that obviously on the one for B, your median is 18.5, but the one for A, your median shows something like around 30. So obviously, you're going to say B is the correct one that represents the data. So to answer 1.3.1, B is the one that represents the data, and the reason being the median is 18.5 because you've calculated it. You can choose any other thing to calculate to prove that B is the correct one. You can talk about interquartile range. You can even talk about the estimation of the mean, right? But otherwise, you have a lot of information to can say. But then any answer is acceptable as long as you say B is the correct box and whisker diagram that represents the data that is given about the bread. And then now, just in closer, 1.3.2, 1.3.2, just to close the whole thing now, 1.3, 1.3, yeah, 1.3.2. They want us to describe the skewness of the data. Here, we can see that the mean is more than the standard deviation. The mean is more than the median. And if the mean is more than the median, we can say this is skewed to the right. I'm not going to go deep into the explanation of this, Mara. I'm going to have a video where I'm explaining the skewness properly, but this is positively skewed. Let me say positively skewed, or skewed to the right. Positively skewed. That should be my answer for 1.3. Reason being the standard deviation is, but there's also many other reasons that I can say is positively skewed. Other than that, I just wanted to conclude the question paper without leaving it hanging. Yeah, man. So that's the story of the bakery and the bread and the tuck shop. But the punchline of the whole conversation for today is to remember not all questions you have to look at, or rather, not all mathematics questions you have to approach them as if it's a foreign language of some sort of algebra whereby it's X, Y, and Z. When coming to statistics, guys, it's something which I think you can build up to understand also the algebra one of the good days. But also, if you want to follow a career in data analytics, data science, and stuff like that, you must invest more in the knowledge of statistics, because like now, it's the very same study of real life events or real life situations, which you must analyze in numbers and calculate them in the standard deviation and all the other things just to compare. If I can talk the whole day. Anyway, to make this video short, please subscribe. Please follow us in all social media platform. I'm Mr. Maimane. This is Simplified RSA. The guys makes it looks easy. And also, you can have you can access our classes also on Spotify, which is an extra media platform. Anyway, yeah, man. But I feel like Spotify is so cool, man, and no one is watching Spotify. Anyway, yeah, man. I'm out. Until the next one.